Hello, everyone. Welcome to Approach to GMAT Questions segment. My name is Joshua Ubuya, a GMAT trainer and coach with the Kenya ELIT program. We'll bring you questions that are from the GMAT exams and show you how you can approach them in both quant and verbal sections. You check out our other videos to find out more. In this session, I'd like to look at mixture problem. There are mixture problems in the GMAT exam under the problem-solving section. These questions present themselves majorly under the word problems category, and they stem up from the ratios problems when you're preparing for a GMAT exam. So in the topics you look at, you'll find these mixtures problems more or less presented under the ratio problems. They are a combination of two main topics, if I may say. One of them is the fractions aspect, which actually is an aspect of the ratios, and the other one is the algebra. Algebra being actually the form that you will be using a lot in addressing these questions. So the knowledge of how these two come to play really helps you in being able to approach these problems. So we'll take a look at these questions and see which various ways that you can approach them to be able to get to an answer. So without further ado, let's dive into it. So the first category of questions you're looking at are sub 600 level question. This is more or less a question which is not deemed to be difficult. Many should not have much difficulty to get the correct answer. But nonetheless, what is the required approach? The main focus for this video is the approach you need to have to be able to get answers quickly and also more accurately, and more or less hit what the examiner is testing overhead. That is what we're looking at. So, a club wants to mix 20 pounds of candy worth $8 per pound with candy worth $5 per pound. Reduce the cost of the mixture to $6 per pound. How many pounds of the $5 per pound candy should be used? Yeah. You can pause this video, attempt the question, then resume, then actually just unpause it and see how we can actually go about this question. So in this question, if you're looking at it, what we're looking at first is we're looking at there's a mixture here. And it may be for what problems, if you don't know how to convert them into a mathematical problem that can be solved, it can be a challenge. So the first thing you need to be able to do is be able to form an equation for this, okay, or convert it into an equation, because it's saying you've asked for an unknown. What do you know? We know of 20 pounds, which you're being asked for. We know the price per pound for this 20 pounds is $8. Then we have another one also. We also have another one which is $5 per pound. Yeah. And they need the cost to get to $6 per pound. So don't have the quantity. You have the quantity of the $8 one, which is 20. We don't have the quantity of the $5 per pound candy. And then we have the target. So for this one, how do we go about it? How do you convert this into an equation? How do we present this into an equation? And then also be able to address it. Yeah. So here we can, what you can start by knowing, if you're actually being asked for the price per pound, which you're looking at to be $6 per pound. So how do we get these $6 per pound? So price per pound will be equal to total price divided by total volume, total weight rather, volume, weight. Yeah. So we have one, let's give them just let's say you have y, which is 20 pounds at $8 per pound. Yeah. Then you have x, which is x pounds at $5 per pound. And call that 5 per pound. Then you have a target of x plus y. We should have 6 pound. No, x plus y at 6 per pound. $6 per pound, right? Yeah. That's what we need to have. So total price for this mixture will be the quantity, the number of pounds times the price per pound. That is what it is 20 times 8 plus, for y we'll have x times 5. Then we'll divide it by the total weight, which will be 20 plus x, and that should give us the pot price 6. So if we have this equation here and solve this equation, we should have our answer of how many pounds do we have of x. So that is what we're being asked. The pounds of x that you require to be able to have the price get to 6. So let's expand these. Let's actually simplify this equation. We'll have 20 times 8 is 160 plus 5x is equal to 6 into 20 plus x. So we'll have, if you open the brackets and collect them together, we'll have 6 times 20 will be 120. If you bring it to the other side of the equation, you'll have 160 minus 120 is equal to, and take x, this 5x, the other side will have 6x minus 5x. This will reduce to x being equal to 40. That will be the value of x, the amount of weight that is required in x, to be able to bring the weight down to $6 per pound. Yeah, so x is 40. That is answer choice C. Yeah. So for this kind of questions, these are questions which just require you to have an equation, plug in the values, and you get your answer. So that is, so basically what you're being tested here is, can you convert these word problems into a mathematical problem and solve it? That's basically what you're being asked. And that's what you expect. So on to the next question. We have actually a question also, which is fairly easy still, requires also more or less the same approach as the previous one, but let's see how it goes. Solutions A, B, C, and D contain 20%, 40%, and 50%, 100% alcohol, respectively. The four solutions are mixtures are mixed in proportion of 1 to 2 to 3 to 4, respectively. What will be the percentage of alcohol in the resultant solution? So we have mixture A, B, C, and D. Each of them have different composition of alcohol, and you're mixing all of them together, and you will actually know what proportion of the mixture is going to be of alcohol. Pause the video attempt this, then come back and take a look at it. So as you may look at this, one challenge with the ratio problems is presenting the ratio forms as they are 1 to 2 to 3 to 4. You need to know how to convert these ratio forms into fractions. That's one thing that is normally tested. At the same time, also need to know what approach you're going to use to be able to translate these mixtures, these percentages into mixtures, and get a concurrent, conclusive value that you can work with. So we have alcohol and we have no alcohol in the mixture. Then okay, we have the whole volume of the liquid, because we have alcohol and the other. It could be water, it could be another mixture altogether, or another drink. We don't know, but that does not matter. How do you approach this? We have the ratio aspect, the ratio of A to, let's say, A, B, C, and D. If you actually convert them to fractions, is actually you can have them in the form of x. We have x to 2x, 3x to 4x. That's the formula that you do have, or rather, let me just write them somewhere more visible. X to 2x to 3x to 4x. Yeah, that is how actually you can present these ratio problems, so that you can get to know the magnitude of each mixture over the other. So you have A being 20%, also B being 40%, C being 50%, and D being 100%. And so what does that mean? This is actually the volume of alcohol. So if it's 20%, you have alcohol part here. Alcohol, then you have volume. Yeah, let me just put the mind. So you have let's start with the volume. then alcohol. Because the resultant mixture is going to be mixed up. We have A, B, C, and then D. So for such type of problems, Eric, it's recommended to have actually work with real numbers that can really help you visualize these values well. Yeah. Yeah. Let's say if actually we have a mixture of, let's say, if since actually if you add all these, they get to, let's see the ratios. The ratios will be 1 out of the total number is how many? 1 plus 2 is 3 plus 3 is 6 plus 4 is 10. So you have 1 out of 10. And then B will be 2 out of 10. C will be 3 out of 10. Then D will be 4 out of 10. That will be the proportions of these mixtures in the total resulting mixture. So if actually you say it's, let's say the total volume comes to 100, we need to know what proportion, what volume of this mixture is going to be alcohol for us able to get the percentage of alcohol in all this. Yeah, so if it's adding to 100, then what's going to be the volume of A in this one? So a tenth of 100 is going to be 10, of B is going to be 20, C is going to be 30, and D is going to be 40. That is the volume of the liquids as they are mixed. Then what is the volume of alcohol in these liquids? That is the next thing we need to find out. So if 20% of A is alcohol, then what volume is alcohol? That become 20% of 10, that becomes 2. And then what 40% of 20? 40% of 20 will be what? 40 will be 8. Yeah. 42% should be 8 because actually, yeah, that is 10%. 10% of the 20 will be 2 times 4 is 8, yes. 50% of 30 will be 15. And then 100% of 40 will be 40. If you add all these, what do you get? We have 10 plus 5, that is 15, carry 1. Then 1 plus 1, 2 plus 4 is 65. 65 over 100, that comes 65%. Yeah, and that is your answer, is choice D. So instead of trying to figure out how do you present this and the other one, or going about equations and everything, just logically think of it, because actually it's a percentage of our volume, the whole volume as it is. Just think of it in those manners, and then now you can be able to approach them. Now, as you go higher to higher difficulty questions, you may be required to add more logic, or maybe also add other aspects or other topics, concepts from other topics to be able to address the problem.
You're watching Success with Bob Mwiti Show, presented to you by Upstech America. Upstech America is a consulting company that helps immigrants find amazing higher education and job opportunities in the tech industry in the United States. You can find our programs by going to www.upstechamerica.com. Upstech America, we wake you up to the unlimited potential.
Solution A is made up of 30% vinegar and 70% oil. And solution B contains 10% vinegar and 90% oil. If the two solutions are combined to produce a solution that is 15% vinegar, solution A comprises of what percent of the new solution? So you can pause the video, attempt this question, and pause and see how to approach it. So we have two solutions here, and they're all being combined to make one. So for such type of questions where you see there's more or less like something that looks a bit murky or multiple combinations that need to be put in place, I prefer using the matrix method. And matrix method is basically just drawing a table or a matrix that can help you organize your information and break it down to something which you can solve. So you have mixture, solution A, and you have solution B. Solution A contains vinegar and oil. So you have V, then you have oil. Yeah. A contains 30%, which is more or less 0.3. And of not really oil, but just a moment to erase this. Solution A contains 30% vinegar, 0.3, and 70% oil, 0.7. Solution B contains 0.1 vinegar, 10%. Solution and 90% oil, that is 0.9. And then we have both of them mixed together. You have A and B, A plus B is on the side. Solution A plus B contains 15% vinegar, that is 0.15. Now, in this mixture being asked for what A is, what percentage of this mixture is A? Yeah, for instance, that's just being asked what proportion of this mixture is A in percentage form. So with this laid out, we can see that we have more or less like something that can be worked with. We have this line of equation that we can work with because we have A contributing to B, A and B contributing to A plus B. We can call it C or just have it as A plus B. So let's form an equation from this. We have 0.3A plus 0.1B is equal to 0.15 into A plus B. So you can remove the decimal points by multiplying all through by 10, or actually you can just multiply it by 100 to be able to remove all the decimal points as you open up the brackets. So this multiplied by 100 will have 30A plus 10B is equal to 15A plus 15B. So if you actually collect the like terms together and see what they are, actually simplify this equation, what do we get? If you take 15 to the other side of 30 and B to the other side of 15, so you'll have 30 minus 15, you'll have 15. A is equal to 15 minus 10 will be 5B. So this reduces to 5A being equal to, well, this is actually 3A, not 5A. It's 3A. 3A being equals to B. Because we divide all through by 5, we get 3. So what does this mean? What is the ratio of A to B? The ratio of A to B will be A over B in this case, which you just divide through, have A over B, what do you got? 15, that is now will be A over B will give you 1 over 3. So 1 over 3 is the ratio of A to B. That means the resultant mixture of A plus B will have A and B the ratio of 1 to 3. So if you're being asked proportion of A in the mixture, proportion A contributes only 1 part in the whole 4-part mixture, because the whole part mixture is actually 1 plus 4. So the proportion of A will be 1 over 4 times 100, which will be 25%. That is just C. So it looks a bit messy, it looks a bit difficult, but when you simplify it, you have an equation which you can work with and you can solve it to get your answer. And what is being asked is how do you convert an equation, or actually as what do you call it? Just an algebraic expression to a ratio, and from the ratio to the part problem that you're being asked. That's what you're being asked here. And once you solve that, you're good to go. So let's look at the next question. Awesome. In this question, you're being told that 2 tanks of similar volume are full of a mixture of oil and water. In the first one, the ratio of oil and water is 5 to 8, and in the second one, it is 7 to 19. If both of these tanks are poured into a large tank, what would be the resultant ratio of oil and water? So also this one looks a bit difficult because you have 2 ratios and you have to combine them into one. You can convert them into fractions and then can solve them, or you can find a value that you can work with, a number that you can work with, then convert the proportions of fractions to now values, then you can add them and go back to finding the ratio if you want to. So let's take a look at it this way. Let's have actually the table format that I found. Let's visualize this problem. We have tank A and tank B. Tank A has oil and water. Yeah. So does tank B. And the mixture is A plus B. So the oil and water, the first tank A has oil and water in the ratio of 5 to 8. So you have 5O. Then you have 8W, this mixture. Yeah, all of it will add up to about 13. Okay, add up to 13 if you have to have it that way. And also the same time, also in the B, we have it as 7 or and 19 W. All these actually, these are just putting them as notations, but in actual sense, these are actually 5 out of 13, and this is 8 out of 13. This is 7 out of 26. This is 19 out of 26. Yeah. So the whole mixture adds up to 13. But for us to have actually, what we've been told is that they are of similar volume. So we need to have a similar value to work with for us to be able to go about solving this problem. So we look at the denominators, we have 13, 26, 13, 26. We need to make one be equal to the other. And it's easier to make the 13, the A, be equal to B by multiplying it by 2. So that way now we have the equal parts. So if you do that, you'll have 10 of the water, of the oil, and then you'll have 16 of the water. And then for B, it will remain as 7, the oil, then 19, the water. So this one actually, if it is this way now, if they are coming together, then you can add them, because this will be 26, this 26. If you add all through, we'll get the total proportion that each of them contributes to the whole mixture. 10 plus 7 is 17. 16 plus 19. That will be what? 6 plus 9 is 15, carry 1. That will be 35. Then all this together will be 52. Yeah. So if you look at it, this we can have this actually this mixture of A and B will have 17 out of 52 of oil, and then you have 35 out of 52 of the water. But we've been asked for the ratio. So the ratio will just be 17 oil to water, just as it is this way, 17 to 35. That is answer choice C. Yeah. So the ways you can look at it are apart from just having them as tables, but the logic behind it is if actually to have them and they are equal, you need to have them as equal so that you can have the math easier. Yeah. It doesn't matter. You could even make it double, but then again, also ratios, you have to simplify them the simplest form possible. Can you simplify it beyond 1735? No. If it were higher, it could have been, say, 34 to 70, because actually, if you could have them, because actually they have to be the same for them to be added using a multiple of the denominator as the guide for the volume to use in this. So that's normally the biggest thing you need to look out for. That's it from today. If you like this video, share it with your friends and other people. If you also have questions, kindly post them. And until next time, bye-bye.